Hi everyone, my name is Gus Lerm. I am a PhD student from the University of Canterbury, currently working at the University of Auckland, and I'm going to give a presentation on some of my PhD research, which is a topic called LivePublication. That's an effort to integrate our eResearch software and infrastructure with publication containers to solve some of our modern publication challenges. This was discussed last year by Mark, but I won't quiz you on it. And the presentation here is just going to give an update on some of the work we've done post that presentation. So what we're interested in here is expanding what's included within our publication containers and enriching those publication containers with more information. Primarily, we use PDFs or increasingly web-native articles to describe and communicate our research. Fair and open science initiatives have been developed in response to reproducibility challenges and open access for data and methods. These are a few of the challenges that are associated with our current publication containers. One of the big developments in the past 10 years is the use of co-publication, where we publish research artifacts external to our publication container, think things like code and data. What we want to do is, rather than publish these artifacts external to the container, is to integrate those with the article itself. Here we see our publication container, which is no longer just an article, but also contains data, methods, and computational workflows. A few technologies already attempt to integrate these. Probably the most popular is Jupyter Notebooks and other literate programming environments that integrate code and execution capabilities with narrative text. Some technologies expand these containers further through digitizing previously analog processes, such as note-taking for experiments, and then using those new digital artifacts to enrich the publication even further. What we want to do, can I just scroll down on the notes, thanks, in this slide? Thanks. These new integrations are motivated by maturing eResearch technologies and infrastructures, such as virtual laboratories, virtual research environments, scientific gateways, and workflow management systems. These are just some of the examples of research platforms that have matured to a point where we believe there's an opportunity to orchestrate these together to create new publication containers. But this isn't complicated enough. I believe we can also add another dimension, and that dimension is time. When performing research, our methods and data are consistently evolving, and our publication containers don't. We treat our publications today as historical documents, a static snapshot of research performed. What if the article that we communicated evolved alongside our methods and data? How would that change our relationship to longitudinal studies, the publication systems, and what publications generally are? With the research here, we view liveness as an alignment between evolving research artifacts, code and data, and the publication. Generally, this means that changes in the method and the data result in downstream changes to the publication itself. This is one of the primary goals of the research, to quote-unquote enable liveness in our publication containers. So to enable liveness, there are two main aspects to a research article that we need to reconceptualize. The first is that an article itself needs to be no longer considered a separate write-up or a static snapshot of the science that took place earlier. It instead needs to be an integrated and derived product from the computational work itself. Second, that publications are no longer static. This centralizes the findings of a researcher's hypothesis into a single article with many possible revisions or versions. Together, these mean that an article is no longer a historical document, but a live document through its integration with eResearch technologies. For example, imagine a methods section generated using a workflow's description. This could happen automatically each time an article is generated, incorporating new descriptions dependent on changes in the researcher's method. These ideas are built into the goals of LivePublication, where a live publication is re-executable where parts or possibly all of the publication exists only because an experiment has been executed. It's live, where the article's content reflects changes in the researcher's processes and experiments. It's complete, where we capture as many of the digital artifacts available to us within a single container. Transparent, where those artifacts are actually integrated and used to enable transparency within the article. And interoperable, which is LivePublication meeting its goals as a framework, being flexible to many different eResearch technologies. Before we discuss the framework, we should narrow the scope of the technologies we're using. First, we have workflow management systems, which automate some of the complex computational pipelines and conceptualize those pipelines as discrete tasks executed in some sequence. In the context of LivePublication, workflow management systems provide the foundation for the automated re-executable component and grounds it in the research that's being performed. We're specifically looking for workflow management systems that are robust and capable of long-term operation, as a LivePublication's longevity is directly related to that workflow management system continuing to run. Second, there is the provenance data model, which we use to record the internal state of the workflow execution. So provenance is divided between two perspectives. We have retrospective and prospective. Retrospective describes what happened during a workflow and information such as the state of each variable and what they're resolved to. And prospective, which describes what the intended execution was, the plan of how it should happen. And finally, we have our research object standards, which help us wrap up all that information into portable and interoperable formats. Here is a simplified figure of the LivePublication framework. You can think of it as two separate processes with integrations between them. The first on the left, the experiment infrastructure, is a vertical slice of the eResearch process. Layer 1, the data producer, represents some data source, ideally one that's producing data frequently. Layer 2, computational method execution, represents our workflow management system, where we have a workflow running with some infrastructure. And layer 3, where we store the results of the experiment. On the right, we have the publication process. Layer 1 represents a content generation mechanism which creates and curates the content of an article. Layer 2 creates the presentation container, whether that be a PDF or a born digital or web-native container. This includes formatting and stylization. And layer 3, which are meta processes regarding publication. These address how we version these products and how they fit within our current publication system. Between these processes is an interface. That component integrates each experiment infrastructure with its publication generation system. How we get information out of that experiment infrastructure is going to be the topic of today's discussion. The interface is effectively a provenance container that describes what happened in the experiment infrastructure. From here on, we assume that a workflow is distributed. We also require granular information, meaning that we need to be able to understand what happened in each step of the workflow. And we also like that information to include hardware and performance metrics. To model this provenance information, we lean on the workflow run RO-Crate profiles. These profiles are written in the RO-Crate standard, which is an effort to standardize provenance representations for computational workflows. These come in a set of three: the process run crate, the workflow run crate, and the provenance run crate, with each standard extending the last with additional provenance information. We require granular information, so we start from the most descriptive profile, the provenance run crate. It models each step as a set of its own entities with connected parameters and results. The challenge of this profile, and generally with workflow provenance models, is that they often assume a centralized workflow management system. That makes it difficult to deploy them in distributed environments. This model also doesn't include hardware performance entities, so to solve these challenges, we specialize this profile into a LivePublication specific model. So to specialize that profile, we identify the entities that are associated with stepwise provenance. Here, I've highlighted the entities which describe the action and its associated results in software. These entities, for our use case, would be the entities that we want embedded at the distributed compute and would include things like hardware and performance. To replace these, I've created the distributed step crate, which is a discrete RO-Crate specification for the specific purpose to be generated at a compute node. It's designed to be consumed by the larger provenance run crate model at the end of the workflow's execution. The subcrate profile describes the outputs and results of a step, subscription requirements for access to that compute, and hardware runtime information and performance data. Finally, we encode some position data in the how-to step entity, which becomes important when we come back to reincorporate a set of these distributed step crates with its parent provenance run crate. Without that information, we wouldn't know which prospective entities to align this retrospective provenance with. So here I've put the provenance run crate specification with our specialization for distributed provenance recording. You'll note that not all of the entities in the distributed step crate are included here. Some are removed when we integrate these. For example, the distributed step crate's how-to entity is consumed by the provenance run crate's how-to step entity. The result of this is a provenance run crate specification that addresses the challenges of provenance recording in distributed and federated environments. Now we have the joy of applying a purely theoretical data model to real-world applications. For our application, we chose Globus Flows with Globus Compute. Globus Flows is an automation and workflow management system designed for research computing. It enables researchers to orchestrate complex data movement and computational tasks across distributed resources. Globus Compute is a function-as-a-service action that can be orchestrated within a Globus Flow. It unifies access to heterogeneous resources for users to run computations with. Combining compute with flows gives users the ability to define computational pipelines. If you want to know more about compute, Ryan Chard is giving a presentation on this tomorrow afternoon, I think. Yeah. To integrate Globus flows with LivePublication, we need to be creating provenance records using the LivePublication Prov standard. That requires two developments. First, we need Globus compute to produce distributed step crates. And second, we need those crates to be consumed to create the provenance run crate. I'm just going to provide a really simple overview of these developments for time. It's relatively simple thanks to Ryan and his team at Globus to extend the Globus compute with some custom logic. We edit a helper script which is invoked on every incoming job and wrap the execution of that job with our distributed step crate embeddings. This gives us access to hardware performance metrics, executed functions, input and output data, and some contextual information about the user and the compute environment. Finally, we write the distributed step crate to a temporary directory. Now we have Globus compute nodes generating distributed step crates, and we need to manage those crates within the system, preferably with minimal user input. For that, we modify Gladia. Gladia is a Python SDK that abstracts some of the more complex flow definition writing tasks away from users. Normally, users create Globus flows through Gladia. They define their computational tools, different databases, computational endpoints, and a Gladia client. That client generates flow definitions from its components, registers and runs them with Globus. What we did is extend Gladia to the Gladia client to include some automatic flow generation behaviors. If users use a provenance client when generating their flow definitions, transfer steps for distributed step crates are automatically added to that definition. This lets users define flows as they would normally and moves all of the distributed step crates back to a management node. Once centralized, we can use the LivePublication provenance model algorithm to create a complete provenance run crate. For most of this presentation, we've been talking about extracting information from the experiment infrastructure. Now we're going to quickly touch on how we're using that information to meet the goals of LivePublication's live articles. For a case study, we use Quarto, which is a literate programming environment similar to Jupyter Notebooks. Using this platform, we're able to change the article's content dependent on provenance information that we receive from the experiment infrastructure. Some behaviors shown in the video are things like inclusion or exclusion criteria for statements and words and delimited text, which will only appear if variables fall within certain ranges. There are some more advanced behaviors like generative summaries, which use information from our provenance run crate. This approach is limited because many of these behaviors must be encoded within Quarto's code blocks. For example, switch statements for Markdown. This ends up feeling a lot like writing if statements to print the Fibonacci sequence. What we need is a more flexible document format that lends itself to procedurally modifying its content. To achieve a more dynamic document format, we're integrating with Stencilla, a research-focused writing platform. Like Quarto, it integrates code and data, but its strength lies in its dynamic document model. Each Stencilla document is powered by a DAG that describes how narrative and computational components interrelate. This model aligns well with our goals. It makes it easier for authors to create dynamic documents. Authors can define if-else blocks within the DAG based off variable evaluations, and more recently, Stencilla's introduced LLM integrations with some more robust transparency measures. Another bonus is that Stencilla records the provenance of changes to a Stencilla document. So with Stencilla recording the article's provenance and us recording the provenance of an experimental system, we now have a complete provenance chain from experiment through publication. We're developing a VS Code plugin to extract metadata and artifacts from our provenance record to make them more accessible within Stencilla systems. And finally, here's a quick demonstration of an early version of LivePublication using Quarto, where we manually trigger a compilation of a manuscript to our provenance. Usually this happens automatically, but it's useful to slow it down. Here's Globus. People can collaborate and access the same flow executing our compute nodes. Once those have generated their distributed step crates, they're uploaded to a management server, which will generate the full provenance run crate. Once that's done, we can select a manuscript to preview or render of the publication, and if we're happy with that manuscript, we can push it to Git, which is a quick look at how versioning systems may interplay with this sort of publication system. There we go. So in summary, we're expanding the publication container to include research artifacts that evolve over time. We developed a provenance model for distributed first contexts, applied it to Globus flows, and used the resultant insights to enliven a Quarto document. Next, we're exploring Stencilla. LivePublication unifies the research and publication processes, making our articles an emergent property of research performed. And if you have any questions, I'd love to take them. Thank you. If we have time.
I think we have time for a few questions here. Anyone? Well, I have a couple of questions. I was just wondering, Are you working with a particular research group, or is that something that you're developing on your own at this point, and you want to? Are you looking for some researchers that you see?
For case studies. Well, very interesting case studies right now, but there's a little bit of maturation that needs to happen. But Mark and I were looking at some case studies that would be good to use for this sort of system. Yeah.
I guess, maybe a question from.
So the research literature is a web of citations of documents.
Mm-hmm.
So say I'm citing somebody who's using the system. So say I'm citing somebody who's using the system, and that person reruns their workflow, their if-else statement triggers, and their conclusion has changed. I've cited the earlier version of their work. So how does this fit into the whole
that's
web?
a benefit and a negative depending on your perspective. The idea, this is an advanced idea that we haven't looked at experimenting with, but you could create dependency chains between documents. So if your work relies on some monitoring that's happening in the environment to be within certain thresholds, and this document is presenting those as APIs for you to call, you can then invalidate a chain of work, but you would have to obviously have static versions of these documents that you can reference without the fear that they will change later in your research process, which is why I pointed to Git at the end there. So you should be able to access a static version, which sort of defeats the purpose, but hey, we've got to play ball at some point.
Hi, just over here.
Yes.
Thanks. This is a great talk. This is a great project. I was wondering if you're talking to journals or even GitHub or somebody who's interested in using the system and encouraging researchers to
yes,
make these flows happen.
We've been in contact with one journal. I forget what it's called, Mark. Do you remember? Cool. Well, yes is the answer. Yeah.
Yeah, so we hope that we will at some point be able to create a journal edition that is fully live. So we'll try and pick some science that benefits from the dynamism of being continually connected back to an evolving entity or evolving set.
That's brilliant. Good luck.
Cool.
Thank you. Any more questions? There would be time for one more question. I guess one question I would have is you talked about reactive pages, I think, and have you considered sometimes interactivity as being part of the document, where, for instance, you might have like a 3D picture that you may want to rotate?
Yeah, so that sort of user interaction sort of falls within the purview of the literate programming environment or the publication system that we're using. So I don't want to dive into visualization and user interactivity because that's a lot, like the scope just goes huge, right? Yeah. So we hand that, and this is part of the idea of the LivePublication framework, is that we can integrate all these discrete technologies together, and they can handle what they're good at. And what Quarto and what those literate programs they're good at is visualization and creating visualizations of data. So what we're interested in is capturing that data so they can then integrate with live data that will then be revisualized in the next version of the document. Yeah.